Hello student, today we continue the unit enzyme. So the enzyme you have know, the enzyme is the protein and it consists of simple protein or conjugated protein. That means the enzyme is either have the simple protein or either have the conjugated protein. The enzyme which possess the simple protein, they have consist of only amino acid. So such enzyme is called as a simple protein. And another one, that is a enzyme which are called as a conjugated protein. So this enzyme which have the conjugated protein, they are called as a holoenzyme. So the conjugated protein or the holoenzyme is consist of the protein component as well as non-protein component. So the protein component of the conjugated protein is called as a apoenzyme, and non-protein component of the holoenzyme or conjugated protein is called as a prosthetic group. So this prosthetic group is considered as a non-protein component. That means here the conjugated protein, they have the apoenzyme or the prosthetic group. The apoenzyme is a protein component and the prosthetic group is a non-protein component. So here we can again explain about the holoenzyme. Suppose this is the holoenzyme. So this holoenzyme, they have protein component and this is the non-protein component. The protein component is called as apoenzyme and this non-protein component is called as a prosthetic group. They are always associated with each other. That means when they are not associated, then such enzyme cannot catalyze the reaction. That means here the association of the apoenzyme and this prosthetic group is very essential for completion of the reaction. And this holoenzyme, that is apoenzyme and this prosthetic group, if they are separate or dissociate, so this alone apoenzyme cannot catalyze the reaction. Similarly, this prosthetic group is also cannot catalyze alone the reaction, and therefore the holoenzyme is very essential for the acting of enzyme on the substrate or catalyzing the chemical reaction. So I think you have got what is meant by holoenzyme, what is meant by apoenzyme, what is meant by prosthetic group. So again we repeat, the holoenzyme means they have, it is called as a conjugated protein, that means the apoenzyme, and the prosthetic group, that is a non-protein component and protein component are associated with each other. Then it is called as holoenzyme. The apoenzyme means only the protein component and this prosthetic group is nothing but only non-protein component. So here there is another term called as a coenzyme. So here this is suppose this is the holoenzyme. Sometimes this holoenzyme, they have the apoenzyme as well as the non-protein component, that is the prosthetic group. When this prosthetic group is a organic substance, that means if this prosthetic group or this non-protein component is an organic substance which is associated with this protein component, then such enzyme is called as a coenzyme. That means here the small non-protein molecule associated with the enzyme and which are essential for catalytic activity of enzyme, and this is called as a coenzyme. Coenzyme are organic substance and they are loosely attached to this enzyme molecule, that is a protein component. During the enzymatic action, they act as a secondary substance or it is also called as a co-substance, but this coenzyme or this organic substance is very essential for catalyzing the reaction. Suppose this they are dissociate, they are separate, then this is the protein component, that is apoenzyme, and this is a non-protein component, that is a coenzyme when it is a organic substance. If you take the example of NAD, that is nicotine amide adenosine dinucleotide, as well as nicotine amide dinucleotide phosphate, that is NADP, as well as FMN, that is flavin mononucleotide. So this is the coenzyme, or this is organic substance. They are associated with certain enzyme, and therefore this coenzyme is very essential for for catalyzing the reaction. Sometimes some vitamins are also acts as a coenzyme. Next one, that is a fen in holoenzyme. Fen in holoenzyme, if this additional non-protein substance or non-protein component is a ions or metal, then it is called as a cofactor. That means here the non-proteinaceous additional substance required for enzyme action, and these cofactors are ions of different inorganic element. So here they are inorganic element and they are required for activation of the enzyme. They may be in the form of the prosthetic group in case of holoenzyme. Suppose there is a holoenzyme, then it acts as a prosthetic group, or it may be separate in case of sulfur protein enzyme. For example, Ap++ as well, or Ap+++ bound metal carbon linkage in enzymes like catalase and cytochrome oxidase. In certain enzyme, there are some cofactor. They are associated with this enzyme, and they are very essential for catalyzing the reaction. So here this is some example of the cofactor. That is a phosphatase enzyme have the magnesium cofactor. The ascorbic acid, they have the copper as a cofactor. Certain peptidase as well as alcohol dehydrogenase enzyme, they have the zinc as a cofactor, and peptidase enzyme, they have the Mn, that is manganese, is the cofactor, as well as the nitrate reductase enzyme, which play important role in nitrogen fixation. So they have the molybdenum as a cofactor, and ATPase enzyme, they have also the calcium as a cofactor. That means here the coenzyme and the cofactor. So you have to remember the difference between the coenzyme and cofactor. So the coenzyme is the organic substance and cofactor is a inorganic substance. So both are essential for the catalytic activity of enzyme. And next point here, that is the properties of enzyme. So we have studied the one by one property. We call it as a physico-chemical properties of enzyme. So in that, the first property is a catalytic property. So the catalytic property of the enzyme is nothing but the all enzymes are catalyzed the reaction. That means the enzyme is accelerate the rate of the reaction, and it undergoes any changes in the product as well as themselves. That means the enzyme is accelerate the rate of reaction that does not affect the equilibrium of the reaction, and this enzyme is essential in a very small quantity, and this enzyme activity is represented by the turnover number of the enzyme. That means each and every enzyme, they have the turnover number, and the turnover number is nothing but the number of moles of the substrate converted into product per minute by every mole of the specific enzyme is called as a turnover number, and this turnover number is nothing but the catalytic property. That means if the turnover number is more, then this enzyme is catalyze the reaction in high velocity or high speed, and this catalytic property can be measured by the unit called as a Cattle unit, and this Cattle unit is the unit of the catalytic property. That means the catalytic property or this turnover number is actually the efficiency of the enzyme. If you take the example of the turnover number of the carbonic anhydrase, so the carbonic anhydrase enzyme, they have the very high catalytic property. That means they have the turnover number is about 60 lakh or say, and the DNA polymerase. So the DNA polymerase enzyme play important role in DNA replication, and they have the catalytic properties only 15. So here this is nothing but the catalytic property or the catalytic activity of the enzyme. So this is a very important property of a enzyme. Second one, the reversibility action. So the enzyme can accelerate the rate of reaction in both directions. So the direction is depends upon the factor present at that particular time. That means itself enzyme does not decide the direction of the activity. That means here the direction is depends upon the factor present in that particular time, and enzyme itself does not initiate the reaction, but only it is a speed up the reaction. Thus an enzyme cannot change the direction of the enzyme. If you take the example of this reaction, that is the enzyme starch phosphorylase, so it catalyzes the reaction starch into glucose and glucose into starch. So here this is the reversible action, and this reversible action or this direction is decided by the factor, for example light and the pH. That means here the light and pH is decide the direction of the enzyme. The enzyme cannot decide the direction of the reaction. That means the enzyme is reversibility action. The enzyme have the reversibility action. That means same enzyme starch phosphorylase is convert starch into glucose. The same starch phosphorylase enzyme is convert glucose into starch. So here this is the reversibility action, which is a property of the enzyme. Then the second one, that is the third one, is the specificity. The enzymes are highly specific for their action on this substrate. If reaction involves several steps, then each step there is substrate, and for each substrate there is a separate enzyme is there. That means a particular enzyme is acts on particular substrate. So here with the help of this diagrammatical representation we can understand the specificity of the enzyme. Suppose here this is the enzyme, this is the substrate. So the enzyme have this active site, and on this active site is a similar active site is also present on the particular substrate, and this substrate only is act by the enzyme. That means the enzyme substrate complex is formed, and then the enzyme produces the product. Here suppose there is a separate substrate, then this enzyme is cannot act on this another substrate, because this substrate is specific for this enzyme, and this is the specificity of the enzyme. Next one, that is a heat sensitivity. So here enzyme remain active at normal temperature, and they are deactivated at high temperature, is about 60 to 70 degrees Celsius. Under dehydrated condition, in seed, suppose if you take example of the seed and the spore. So in the seed and the spore, the enzymes are present in inactive stage, that means they are unhydrated, and therefore they withstand up to 120 degrees Celsius, and such enzymes are called as a thermoliable enzyme. So there are some only enzyme they are called as a thermoliable enzyme, but mostly the enzymes are heat sensitive. So here this is a property. The next property is the pH sensitivity. So enzyme active only under particular range of pH, and very high and very low pH it result into inactivation of the enzyme. Generally the enzyme is activate in normal pH, that is neutral pH, and the enzymes are denatured in strong acid or strong alkali. Next property of the enzyme is inhibition of enzyme action. So here the most of enzyme have the active site to which the substrate bind. So here this is the active site of the enzyme, and on this active site the substrate will be bound. it has been noticed that certain other substances which are partially identical, they are identical substrate binds themselves to the enzyme. That means here, suppose in this reaction, this is the enzyme, this is the substrate which is a specific substrate, and this is another substrate. Suppose if we add this another substrate in the same chemical reaction mixture, then sometime this substrate is acts on the enzyme, or this enzyme is acts on the substrate, and enzyme substrate complex is formed. But this substrate is not a specific substrate, it is not identical to this enzyme. Only this substrate is partially identical to this enzyme, and when this enzyme is acts on this substrate, then here the reaction is cannot complete, because this substrate is a partially identical, and this partial substrate or partially identical substrate cannot binds to the enzyme, or this enzyme cannot bind to this partially substrate, and therefore the reaction is inhibited, and therefore this substrate, partially identical substrate, is called as a inhibitor, and that means they inhibit the reaction. And that means here when the enzyme is acts on this inhibitor, then the enzyme inhibitor complex is formed, and inhibitor binds to the active site and directly block the active site, and the reaction is not complete. That means the product is not formed. So such a substrate or such a substance is called as a inhibitor, and this action is called as a inhibition of enzyme action, or it is called as a inhibitory action. If this substrate which is identical to the enzyme active site, if this substrate and enzyme formed the enzyme substrate complex, then only the reaction is complete and the product is formed. But here in this case, the inhibitor and the enzyme formed the enzyme substrate complex, and therefore the reaction is stopped, the reaction is cannot complete. So here this is nothing but the characteristic of the or called as a properties of the enzyme. So here there is a 6